Okay, in this video we're going to talk about using the cylindrical shell method, but rotating around an axis of rotation other than the y-axis or the x-axis. So let's do an example. So in this example here, the axis of rotation is going to be at x equals -1. So instead of rotating around the x-axis or the y-axis, we're going to actually rotate it around the axis x equals -1. So we're adding to our radius. Okay, so let's start with our setup. Okay, so we know it's going to be what? It's going to be the integral from a to b, right? So, and it's going to be 2 pi x f of x dx. Now, the thing is though, remember this is the formula for the circumference, right? The distance around the cylinder. And x represents the what? The radius. So normally if we're going around the y-axis, then the radius is just the distance from 0, right? Which is just x. But now, since I'm going further to the left, now I'm adding distance to where I need to go for the radius of my shell. So that means I'm going to have to add 1 to my x. So that means I have to rewrite this as x plus 1 f of x dx. And so that's where we're going to start. So again, in the textbook, you could see how they derive this. You derive this very similarly. And so instead of, and I'm just going to show you. So in before, when we derived this, we said, let's start with x sub I minus 1 to x sub I. And then what we did was we derived the formula using, what was it? It was, x sub I minus 1 squared minus x sub I squared. So we had the difference of two squares and we split it up, right? But now we're going to now say, okay, well, we're going to have an extra k in here. So instead of having this, our interval is now the distance is going to be x plus whatever the k value is to the left in this case. So we start with x sub I minus 1 plus k and x sub I plus k, because again, it's how many k values we're adding or subtracting if we're going this way, but in this case, we're talking about a positive k value. Okay, so we're adding a k value because we're going out here to some k value here. And so now it's going to be this. Right? And so in this case here, what does the difference of two squares gives us? It gives us x sub I minus 1 plus k times, oh, hold on. Oh, hold on. X plus k. Let me just see it. So difference of 2 squares, so it's going to be a plus this, so a, so it'd be x sub I minus 1 plus x sub I plus x times x sub I minus 1 minus, plus k minus x sub I plus k. Okay, so basically we get the factoring, the special factoring for a difference of 2 squares. And then things are going to start to simplify, and what we end up with is we end up with just adding k to our x value. So again, the setup is pretty much the same. Okay? Okay, so now let's finish this off. So now let's fill in the stuff we know. So we're going to go from 1 to 2. 2 pi I'm going to pull out, and this is going to be x plus 1 times f of x, which is x dx. And so that's going to be 2 pi 1 to 2. And of course this is going to be x squared plus x dx. And of course if we integrate, this is going to be 2x, oops, not 2x, 2 pi times 1/3 x cubed plus 1/2 x squared, evaluated from 1 to 2. And of course this is going to be 2 pi. And what are we going to get? We're going to get 1/3 2 cubed plus 1/2 times 2 squared minus oops, hold on. Minus the same thing but evaluated at 1, which is just going to give us this. And so that's what we get, right? And so now if I simplify this, what are you going to get inside these brackets? Well, you're going to get 2 pi, and what are you going to get here? You're going to get 8/3 and 4/2, right? 8/3 plus 4/2 minus, well, what are you going to get here? This is just going to be 1/3 plus 1/2. So minus 1/3 plus 1/2. And so what do you get? Well, if we get common denominator, this is going to be 16, 28, yeah, 28/6. So you get 2 pi, you get 28/6 minus 5/6, which equals 23/6. So the final answer, let's see, 23/6, so that's going to be 46/6. Which is going to be 23/3, right? Yeah, 23/3 pi. That's right. So 23/3 pi. And you're done. Units cubed, of course. It's volume. Or if you wanted to change that to a mixed number, it is going to be 7 2/3 pi. Okay, that's it. Oh, hold on. No, it's not it. I got one for you. Here we go. So again, if you have trouble, just draw pictures. Use your calculator or sketch the graph. So let's say, so here's the one for you. It says define R as the region bounded above by the graph of f of x equals x squared and below by the x-axis over the interval from 0 to 1. And they want to find the volume of the solid of revolution formed by revolving R around the line x equals -2. So around x equals -2. Okay. Have a good day.